In the most recent few videos, I've introduced you to ideas like how to train your mind, thinking like a scientist, how to stop overthinking. And so the question naturally pops up, should there ever be a limit to our quest for knowledge? And I think the answer is yes, and I'll try to show you some of the ways that there can be limits. Because knowledge is really just this abstract thing that can help us learn more about ourselves and the world. Why would there need to be a limit? I'm asking, are there any questions we shouldn't be asking ourselves? And no, this video is not about cancel culture, whatever that means, and I'm also not trying to be the thought police telling you what you can and cannot think. But when I say that there are certain questions we cannot ask, it's mostly a matter of how we ask them and what the consequences of asking the questions are going to be. Are we willing and able to deal with that? Asking questions can have very real consequences, not just to you, but to people around you or the people that you're speaking about. Think about it like this. If you are someone that has been adopted and you haven't known that your adoptive parents are not your birth parents your entire life, finding out that and then asking the questions, who are my birth parents, is going to set in motion a lot of things, not just in your life, but in the life of your adoptive parents and potentially in the ones of your birth parents if they are still around and want you to be around. So when I say that you have to be prepared for the consequences, it is not something you can get protected from by freedom of speech. Freedom of speech just protects you from government persecution for your political speech. And therefore, it does not protect you from other people saying that you are probably harming other people. And why is it important to understand the consequences? This is why there is science. Science is not to make some kinds of knowledge look interesting and some kind of knowledge look stupid. It is to make sure that there is a community of scientists and academics that check each other's works, hold each other to account, and correct each other's mistake. So that when new knowledge is found, it is checked to the highest standard it can be, and so people can build up on that knowledge. So science is more like a code of ethics, a community that holds each other to account to make sure that the research is as useful as it can be. One way that it is done is by making sure that it is drilled into people that go to university and want to become academics, that you need to justify all choices. When you describe a phenomenon and you want to do an experiment to it, you need to be able to explain why you chose to research this, how it is useful, how you're going to set up your experiment, why that would actually prove what you're trying to prove, which people you're asking. All of these questions pop up, and that makes sure that when other people read your work and potentially check it and replicate it, that they can do something with your results, like, is this what I found or was it not what I found? Slowly but surely, after adding up with that research results that have been checked by other people, you start to build up on the larger body of knowledge. You'll start to collectively learn more about the world, and other researchers can then check your work, they can question it, they can reframe it, they can try it out, they might change the circumstances, and all of that is useful because, again, knowledge is not about knowing what is true and what is false, it's about understanding what makes something the way it is. So science has its own little security system with knowledge. And it's very important because if science, the people that are supposed to know stuff, is going to come out with controversial findings or things that are just not justified, then other people are going to pick that up and run with it. A good example is, for example, Andrew Wakefield, that in the early 2000s discovered that vaccines are not good for children. And lots of concerned parents took that up and became an anti-vax campaign that we still see nowadays. However, his fellow researchers had looked into his work and said, you know what? Your results do not actually bear out the conclusions that you're going to the media with. You are overblowing the problem, or your sample size wasn't good enough, and so why did you do it like this? So his license got revoked and his work was actually redacted. Even though the science system did work in that sense, it doesn't matter because it is still a very real movement of people believing that this guy has been persecuted for his findings, even though they were just bad findings. Don't get me wrong, I'm not saying that academia and science are just great. They're not. There are lots of problems that I will get into in another video. One of such problems I've already talked about in the giraffe video, so please go and watch that. I want to talk today about societal responsibility, because science is not just about getting knowledge, it's about getting knowledge that is useful to people, and sometimes gathering that knowledge can actually be harmful. If you approach science irresponsibly, that is. First, we need to talk about the demarcation problem. In science, there is a huge problem of finding a neat separation between what is actual science and what is pseudoscience. If we look back into history, just like in the giraffe video, there are different forms of science that have been considered very respectable that we now look back on as quite stupid. Think about alchemy, the idea that you can turn anything into gold. Or bloodletting, that if you have any sickness that you just need to extract some blood from your system because that were apparently bad blood, not a Taylor Swift reference, and then because your body can actually refresh that blood, then everything would be cured. Or astrology, no shade to people. All of these things could have been quite respected at the time, but we now consider to be pseudoscientific. And these people, for example astrology people, do not think that they are doing pseudoscience. They are thinking that they are onto something that the scientists are not willing to see. So that is a problem for science to address. That's why I also say that science back in the day was very different than it is now. Quite recently, only like 100 years or so, is that the scientific community has started to become quite this self-regulating organism of people trying to systematically check each other's work and make sure that you're not producing nonsense. If you do not allow your work to be scrutinized by other people, it cannot be called science, even though it might be true. So, science has changed over the last few centuries. It is no longer about who said it, because for most of human history, it was just an elite class of scholars that could practice what they were saying science. They knew stuff, they were supposed to know stuff. And therefore it was not necessarily about what they were saying, then who the person was that said it. It was just taken to be true. They were advisors to kings, for example. Now we think about science quite differently, as a way and a community to find new knowledge. Lots more people can actually do it, but it cannot just be you on the internet posting something in Reddit, because you need to have people of your peers be able to look at your work and say, how did you do this? Why did you make these choices? What are your results? Are you interpreting your results the same way I am? And other people can scrutinize that as well. And so we still make that mistake today. Sometimes we overvalue who the person is that said it, like genius worship, so that we just take whatever they're saying as for granted because they're just the knowledgeable ones. Think about how people think Elon Musk is a great genius because he is good at business. Well, not so much anymore, but there is an entire cult of stans that will just respect every move that he's making because they see him as a genius. You have to make sure that you do not attach too much value to who is saying it. That is a way of the past. So if you outsource your thinking to a person that you call trustworthy or a genius, they can actually make you buy whatever you want. Buying products to help you grow bigger or stop your woman from leaving you. Or even think about buying into some incredibly stupid nonsense just because you revere the person that said it. And just like in a giraffe video, even scientists historically have been guilty of this. Because back in the day, especially for example the French war in Algeria, scientists actually provide a veneer, respectable justification to hideous acts like going to bloody war, or even to why segregation is okay. This problem of hero worship has very real consequences. One of such examples is Canadian psychology professor Jordan Peterson. His claim to fame at the start was actually about overtly lying about the contents of a Canadian bill called C-16. He said that it meant that it criminalizes misgendering someone, and therefore he had to be against it for free speech reasons. That's not actually what the bill said, but he uses his professional scientific attitude to get people to him and say, look, what he's saying is just reasonable, he sounds like a moderate on this, so we gotta believe him, right? And people outsource their own research and thinking about it into him, which gets people to buy into also very conservative ideologies when he starts talking about things he has no knowledge about. Perhaps he does have knowledge about self-help and he has opinions about it, of course, because he is a psychology professor. But once he starts veering out of that territory where he is an expert in and start talking about neurodevelopmental disorders or about the politics, human nature and ethics, all of a sudden people in those fields are starting to question, like, what are you doing? You are making claims you have no justifications for, but the public gobbles it up because they trust him. But where does the scientific community come in here? Because Jordan Peterson has been making factually incorrect claims confidently for quite a while now. Well, what they've been doing is recently it's become a controversy that the board of the school that he was getting his license at said, you know what, if you're going to be part of the community, please take some PR classes so that you do not start spewing nonsense, because it reflects badly on the profession as a whole and we all suffer from it if our profession goes into disrepute. He's been taking that as an attack on his free speech. So in that sense, the accountability of the scientific system kind of worked. They asked him, please start taking some PR lessons before you go make us look even worse. But the fact that Jordan Peterson has gotten so much notoriety even among moderates because of his scientific seeming talks, he derives a lot of his power from the same source that he's now trying to demonize, academia. So, to prevent a PR disaster like Jordan Peterson, what science needs is a code of ethics, a responsibility towards the society that they live in. Because knowledge isn't just created out of context. It is done within a society. And that means not just that you make sure that whatever you research is true, so that people will not be working with false results. It also makes sure that the way you communicate that research and how you ask the question is responsible. Because it can and will be taken out of context by people that do not understand what you're saying or haven't actually read the work. Even if you try to make grandiose claims to get clickbait and the media to pick it up from your research and people start actually changing their life because of it, like, oh, it seems that in the original research that there is a small correlation between drinking coffee and having a lower chance to get cancer. The media will pick it up, people that really don't understand it, and say, it seems that we found a cure for cancer, that you just have to drink lots of coffee. And then people start drinking lots of coffee and having other health issues because of the trust that they had in science. Gradually, people start losing trust in the institution because of that. So even small sensationalized claims that you make in your own research, you might unwittingly help spread misinformation if you do not do it carefully. That means that you have to analyze your results with a critical eye. You have a responsibility to justify the choices that you made in your research, to make sure that it is open and communicated as much as possible with your peers, like this is what I did and this is what I found, so they can replicate it, and that you do not make claims in your conclusions that you cannot substantiate with the research. Grandiose claims is going to harm people down the line. So this code of ethics is especially important when we talk about politics, because real people's lives are affected because of this. I've had to make policy briefs in the past so that you write research and you summarize what it has been done by making pretty graphs and pictures and making a nice title so that the politician will get it on their desk. They'll look at it, and they're not usually the sharpest tools in the shed, so they'll just skim through it, look at the pretty graphs, and then decide, is this issue worth caring about or not? Unfortunately, more often than not, it will end up in the trash. So the impact that you have as a scientist is to make sure that they don't get the wrong message, because they very often might. They are sifting through the research in order to get ammunition for an agenda that they are already pushing. And so you always have to be careful that what you research, even if you try to make headlines, that it is correct. Because people will take it out of context, they will run with it. For example, TikTokers or the media will take the results that they think is relevant and they blow it up saying, look what they found. People start changing their life decisions because of it. And once a piece of misinformation is out there, it is almost impossible to correct. So ethics is not just making sure that what you put out is correct. It's also how you go about finding your results. Imagine it like this. I've worked with this personally. You want to research how a local community views their relationship with their general practitioner. Because if there are people that do not like their general practitioner, they might not go to them often enough to get the treatments that they need. As a scientist, your role isn't just to observe people like monkeys. You need to make sure that you truly understand what is going on. Why are these people distrustful of their general practitioner? Why are these people not going there? Are there historical factors, for example? How do they communicate? All of these questions pop up, so you need to actually engage with people. If you find out how they communicate, you can better understand them, and that's the point. Putting out a survey very lazily to everyone that lives in a certain area will only give you back the results of the people that are happy with their general practitioner, giving you a very rosy picture. So you need to make sure you go to everyone and get a representative sample to get a real image of what is happening. And then the moment you get results, you have to analyze your findings with a critical eye. Data doesn't mean anything without context. So you have to engage with people to understand the context. And the way that you go about engaging needs to be ethical as well. Because you don't want to be like Nazi scientists that experiment on people to find out whether they can withstand fire, for example. Then it doesn't serve the people that you're trying to research into. You're not trying to use them, you're trying to work with them to get more knowledge. Okay. So this video is about how ethics should guide science. And that's not just about what you find and how you find it. It's also about how you look at your results. A big thing for me is numbers. Statistics and data doesn't mean anything without context. And I want you to remember that. During my studies, I have seen many studies that use statistics and numbers. And especially in social studies like political science, most of these studies at best can just find a correlation, that things seem to be related. But when you talk about politics, usually these numbers are just taken out of context to beat your political opponent over the head with it, that they cannot respond to it and just make you seem like you won the debate. But actually, you should have people analyze these results and seeing, is this significant? Is this a good way of going about your research? And quite often, without that kind of analysis, you just get these mudslinging contests of people saying, these are the data stats that support me, so please just listen to me. So you have to analyze your conclusions with a critical eye, because otherwise it might just be taken out of context by people to score cheap political points. There might be other factors as well that can explain the thing that you're seeing much better. If we just look about being black and doing crimes in the United States, a stupid person would say, oh, they seem to be connected because black people are disproportionately more likely to commit crimes. But they do not take into account the fact that historically this increase in people being convicted for crimes is because police were sent into their neighborhoods during the drug war and arresting them for minor stuff. So as a scientist, you have to weigh all the different explanations. So what are the things that could explain this phenomenon? Are there other things that I could better research? Am I using enough data to actually make a conclusion, or is it too limited? Or am I not making too broad conclusions about a very small data set? Put things into context, make sure that you analyze your data with a critical eye so you do not do actual harm with people thinking negatively about entire groups of people because of finding that you did not bother to check. And this is even more important in the time of AI. You need humans behind the scenes to analyze the data because the AI will not understand what it's looking at. Correlation does not mean causation. Let me give you an example of how correlation is not the same as causation. Imagine you want to research the correlation between people doing extreme sports like skydiving and bungee jumping and look at their chances to get cancer and die of it. You might find that these people are much less likely to die of cancer, and you can spice up your headlines by saying, look, these people are more cancer proof. Is this really what happened? Well, there could be many reasons of why these people are less likely to die of cancer. they might be much more likely to die of accidents so that they do not die of cancer. That's too bad. That's at least the reason why throughout most of human history, cancer has not happened as much, because people didn't live that long. They were dying for other reasons, like smallpox, or through infancy, or by getting murdered, or by the plague. So by all of these reasons, they were much less likely to get cancer, because they did not age long enough to be more likely to get it. And so statistics without analysis doesn't mean anything, and it can be twisted in whatever way you want for your political ends. This is, for example, how fascists say that the West's birth rate is slowly reducing and therefore you need to stop abortion, for example. In order for statistics to be useful, you need to put them into context and analyze them as such. So you say these findings are significant, these other explanations are worse, and therefore this finding is worthwhile. So let's pull all of this together when we talk about stakes. Science is done in the context of society, so there are actual stakes for asking some questions and looking into it. Think about the political question of what to do with homosexuality. It's weird that in the US this is apparently a very big issue. We do not know exactly yet, as far as I know, where homosexuality comes from. There is no gay gene as far as we know. And therefore, the possibility is still open that homosexuality is not just natural, so to speak, that you are born with it, but that you have gotten it at some point. A meta-analysis that I've read, looking at many findings, shows that it's more likely that it is something natural, but we do not know exactly what it is, because it doesn't seem to be developed over time. It doesn't seem to be that gay people used to be non-gay and developed to be gay. The question of finding out exactly where homosexuality comes from is very contentious nowadays. Especially in the United States, there are religious zealots that are trying to get rid of queerness and homosexuality altogether. They think that it is unnatural, and so they are trying to have conversion therapy, for example, to shock therapy gay people out of being gay and try to shun them from their communities, all because they think that it is not natural. The best way to defend gay people usually is by saying, baby, they were born this way. And so discriminating against them for something that they did not choose to be is stupid. Just like racism, well, accidentally something that religious people in the United States often do as well. But it is stupid because they can't change it. As a scientist then, if you approach this question, you need to be very careful with your research, because if you somehow do not do it the right way, so that you do not do it with a substantiated way, and you get a finding that somehow being gay is not natural, all of a sudden you justify all of these heinous acts against gay people that might expose them to real danger. And just like we do not know exactly where the gayness comes from, we also do not know exactly what makes people straight. You can use evolutionary biology bullshit all you want and say that it is because the need to procreate through species and therefore people are heterosexual. That doesn't necessarily make it to be desirable though. It just makes being straight being the default setting, not a desirable setting, especially in a time nowadays that it doesn't really matter that much anymore. So what do we know in science about what causes people to be gay? A large meta-analysis that I've read from experts in the field have concluded that most of the things that we know about being gay is correlative. So we do not know what causes it, we only cause things that are related to it. Think about the fraternal birth order thing. That once a mother has more than one child, every child after the first is more likely to be gay. And the theoretical explanation behind it could be that during pregnancy of the second child or the third child, the more busy her life is, that gives her stress, that releases hormones in her body that goes to the belly and influences the development of the child, which makes it more likely to be gay. Think about that you need a peacemaker when you have so many rowdy kids going around. But you don't know this. This is just a correlation. It seems that there are more children gay when there are so many child. What the experts conclude is that non-social explanations have more backing than social explanations. In other words, it's way more likely from the evidence that we have that being gay is something natural, so to speak, that it is before you are born anyway, than it is something that they picked up. It's not a choice, it's not a lifestyle. But that's the evidence that we have so far, and you have to be careful of looking into it any further, because opening this question again might unleash a Pandora's box of shitstorm in politics. Because these religious zealots are just waiting for any scientific study that they can latch onto that concludes that it is somehow not natural and that it is picked up so it can justify their political agenda. So far that hasn't happened, thankfully, and once they get that explanation they'll be parading it around the world whether it is true or not. Until that moment happens that they find something like that, they'll either just going to resist science and saying, science are a bunch of corrupt woke snowflakes and they are protecting the gay people. But as a scientist yourself, you should be making sure that once you approach questions that you do it with great care so that the results of your research are not going to harm people when you're not sure about them. So, science cannot be separated from the world that it lives in. It needs to make sure that it is ethical by looking into questions with great care and that you can back up every statement that you're making so it does not get used by people down the line to shun other people from society and justify their hatred. The world is political, and therefore science will be influenced by politics as well. And it doesn't mean that it picks one side over the other. It does mean, however, that everything that you produce is going to have effects on the world of politics, and so the stakes are actually quite high for you to do science well and with great care. All in all, now you know what it is like for science to be ethical. You need to make sure that what you say is correct, that you go about finding it in the right way, and to approach things with great care, analyzing the results with a critical eye. That makes the limit of science, making sure you are in the bounds of ethics so you do not harm people. If science is going to be an institution that people will trust in the future, it needs to make sure that its messaging is on point. People put trust in the institution, so you need to be responsible about your messaging and make sure that the knowledge you produce actually helps people's lives and not harms them. Well, that's another one. I hope you really like this one. It's a bit more dense and probably a bit longer, but I hope you like it. Please let me know by putting a like and a subscribe and a comment down below what you think of it, because usually these science videos do actually quite well, even though I do not understand for the life of me why that is. If there's nothing further, I'd love to see you in the next one.